In this video, what we're going to do is we're going to go through a stirling engine, and we're going to design the crankshaft, what the counterbalance is. Let's go ahead and move over to the layout. And what we did in the last video, we've created the wheel, we've created the brackets, and then we cleaned everything up because we wanted to tie the layout to the top. Can you move over to the top level assembly? Okay, in most designs, eventually you'll want to be designing an assembly. Most people, well, a lot of people, I'm not going to say most people, will design everything in just a part studio, which is a great way to get started. I don't think that you can handle all the scenarios that you need to get everything done. So we're just pushing everything into the top level part studio just to show you the relationship between a top level assembly and a part studio. A part studio generates geometry and the assembly designs the part. And we're just going through the steps to do that. Today we're going to work on, we've started off with the wheel. Let's click on layout. And our design started with the wheel. You want to click on the folder called wheel and expand it. These are everything that makes up the wheel. Go ahead, shut that down. You can take a look at the bracket. These are all things that look at the bracket. And let's go ahead, close that folder, and then show ISO up there. No, the sketch that has the image.
Is it?
No, it went up.
Oh, I'm sorry. It was grayed out. So
yeah, just
oh,
go ahead
sorry.
and show it. And this is kind of, let's go straight on. Let's go to the front view.
Here, I just want to show it, right?
And this is, you can roll the bar above wheel, the folder wheel. And that's one way to turn them off. So that's the image that we're actually using to construct our stirling engine. Go ahead, scroll all the way down. Let's go over to the top level assembly and let's spin the wheel. Okay, so one thing that I do want to point out while we're in here is, and then an assembly gives you two things. The assembly will give you motion, and the wheel spinning is the motion. More importantly, though, what the assembly gives you are instancing. Of course, we don't have any instances yet because we have a mirrored bracket. But those are the two things. This is the reason why you want to get stuff over into an assembly, because it manages your parts and also can handle instancing. Instancing is just speeds up the process for duplicate parts. Bolts. If I have 1,000 bolts in a design, and if I'm doing that in a layout, you'll wish you hadn't done it that way. Bringing them over into an assembly and using an assembly to handle 1,000 bolts is fairly easy to do. Okay, let's go back to layout. Enough about that. Let's start designing a crankshaft because that's what this one's all about. And let's go ahead and hide the ISO image up at the top of your feature manager tree. We are making use of folders just because it's a good design technique. And we need to first come up with a plan of attack for designing the crank. So let's rotate the image so that we can see an ISO, or see, there you go, that's good enough. And how, first feature is always the most difficult feature in any component that you're doing. And well, let's say I can't even phrase the question. What's our reference for our first feature, right? We're probably going to put a sketch entity down. And then, well, what's the reference for that sketch? And that's my question to you, Carson. How would you get started designing a crankshaft for this?
I might hide the wheel. And then
Sure,
I
let's
get
hide the
the
wheel.
diameter of this inner cylinder.
Okay, all right, we can do that. What I'd like to do, what, if we were gonna put a sketch in here, which sketch, how would you define the sketch?
Um, I think we should make a new one, right? Unless
Yeah, definitely a new one, but what would its reference be? So
should I
go
use?
ahead and create a sketch, right? It's gonna, don't have anything highlighted.
Okay, are you talking about like when
Yeah,
it prompts the plane?
click on it, click. And what's the reference? What's it asking for?
It's asking me for a sketch plane.
And that sketch plane is the reference for the sketch. And we need to pick it wisely. Which one would you pick if you needed a reference for the crank?
Would I be able to do one of these surfaces or?
Yeah, you can. I would discourage that, but you can do that. And my reasoning is that the crank really doesn't have anything to do with the bracket. Okay.
Okay.
Um, it does kind of, but I'm not so certain that that's what I would tie it to. If I update the bracket, do you want the crank to update with it? And you could argue yes. I'm saying at this point in our juncture, that's not what I want. I would pick front and just tie everything to a higher level reference and the front plane. Most of the references for the bracket for the wheel have been the front plane, and we're just going to continue that down. Okay, so you can go ahead and turn that off. You can turn your brackets off too if you want, and we will bring them up. And you need to hide your bracket mirror, and you can even turn your planes off now. Now, we've never really started with a layout sketch. With this crank, we basically have a linkage. And what I'd like to do is to start off with this sketch isn't going to dictate size. This sketch is going to dictate a layout, the layout of the linkage that we're going to be working on. So I'm going to try to describe to you what the links are in the crankshaft that we're developing. Hit the N key on your keyboard, and that goes normal to the front plane. And what I want to do is I want to create a line that starts at the origin. So go ahead, create a line. And starts at the origin and drag it off to the right and drag it down because I do not want it, I don't want it to be vertical. I want it to be free. Go down a little bit. Oh, that's fine. Okay, now, hold on here. That's good. You know what? Let's open up the folder wheel and turn on image because that's the side view. It's kind of a bad side view. And so what I'm trying to do, go ahead and hide that image. I think the image for bracket is better. And shut down that, go into the bracket folder, turn that image on. Yeah, that's more appropriate because at least our linkage is in the middle. So to try to illustrate what I'm talking about, the end of the line, there's a crank pin. Go ahead and move the line to the crank pin, holding the shift key down.
At this end?
Yeah, and drag it over to, nope, not that one, to where it connects to the rod. It's not a very long line.
Like that end?
No, the pin where you need to go down. Yeah, no, I'm having a hard time explaining to you where I want it.
Which direction should I go from here?
You need to go over to the left and down, down. up, up. You see where
Did this
that's
guy?
it. The center of that little, the center of that. Okay, let that go. Okay, now I want to create another line that mimics where that rod's going down. That rod goes down into that cylinder. That rod goes down into that cylinder, and I want to find where that rod attaches to the cylinder inside. And, you know, right now we're guessing, right?
Yeah.
Okay, so click there. All right. And that's pretty much what we want. Let's dimension the short leg of the linkage. And we can call that 4. Let's see what 4 looks like. Okay, I like 4. And now let's dimension the long, and we'll call that 43. And then the one thing, the end of the long leg of the, yeah, click that, click, well, I think you're dimensioning, so escape out of dimension. Click that, click the origin and hit the V key on your keyboard. Okay, so what that did was it says the end of that line will be vertical to the origin. If that's true, I don't know, but we'll figure this out here in a little bit. I need for you to grab the vertex where both lines come together, hold the shift key down and rotate that around. Keep going all the way around. What do you think this crankshaft's going to do?
Exactly this.
Yeah, so go ahead, put it back on our image so that it'll be, to be honest with you, we should probably put it down because it'll be easier to draw the crankshaft if it's in a, but hold the shift key down because we don't want it to make an assignment.
Yeah, it's
Okay,
down.
so go ahead and click. Okay, so I want you to call this layout and exit the sketch.
Sorry, what do you mean call this layout?
Go up to sketch 5.
Oh, sorry.
Yeah, and we're going to make a folder called crank. Say okay. No, it's going to be the layout. Say okay. And right mouse click and put that in a folder called crank. And there you go. Open up crank. Layout. What do you think the layout does? Tells you what the crank's doing. Okay. What does the crank do? It's 2 lines. It's 2. Actually, it's how many links is it? 2 links? It's actually just 2 links, right?
Yeah.
It has some constraints. But what it's going to do is it's going to explain to us the motion that we're going to be putting forth, okay? So let's go ahead and start. The first thing I think we should do is create a shaft. So
Okay.
you may want to start your bracket and highlight. Do you remember what the hole size was?
Oh no, I didn't
Yeah.
grab that.
To me, I would, let's show wheel down below. And just go ahead and pick that diameter.
3.2.
And, okay. So let's go over some engineering terminology. 3.2 is a clearance hole for it's pretty loose clearance hole for a 3 millimeter shaft. So what is the nominal size of our shaft? Nominal size is 3. So we're going to have a bracket, we're going to have a wheel, and we're going to have a shaft. All 3 of those are going to be playing around with a 3mm shaft. So we need to make some decisions here. One, what's the diameter of the shaft? We're going to have the diameter of the shaft to be 3. So we want to create a new sketch on front plane, and we're going to create the shaft. Front plane. Say, and then put in a circle. You can hit the C key on your keyboard. And yep, and put in a diameter of 3. All right, so we should probably call this sketch size because it's dictating some size here. And say okay. Typically, when you go buy a shaft, you will say, I want my shaft to be 3mm, and you can buy shafts that are 3mm, plus nothing, minus nearly nothing. Do you want to press that wheel onto the shaft?
That'd be nice.
Yeah, so we'll have a press fit. That means that we're going to have to specify the whole diameter in the flywheel to be 2.9, 2.95. That means that you're going to have an interference. Our shaft cannot be less than 3, can be greater than 0.05. And then the brackets, we're going to stamp that out. Those will probably be possibly clearance holes. If we buy this from Misumi, we can buy a precision shaft, and we can also have them thread the ends so we can use bolts to bolt this all together. I think that's beyond the scope of what we're doing right now, but that's basically where you're starting to make your decisions as to, I've got a shaft. I always like dealing with nominals. It's also one of the reasons why I don't like dealing with US dimensions, because their nominal is in the middle of the tolerance zone. And to me, I like the European way of doing it, where you establish a 3mm as your nominal, and you work higher on some items, you work lower on some items. Do you want it to be clearance? To me, it's just cleaner to work in your tolerance zones using the European standard. Anyway, enough about all this. Let's go ahead and take size and let's extrude it. We're just working nominal right now, but we should be starting to define our tolerances, and if I want press fits, if I want clearance fits. I think that's out of scope on this. Okay, so if you can show a bracket, you kind of know how long this thing needs to be. So go down into your parts and show a bracket, and go ahead and expand the depth. Yeah, you can eyeball it in. I want to go beyond the bracket. I don't want it to be flush because it'll never assemble right. Plus, we're going to put a nut on the outside of that. So we'll nut the inside, we'll nut the outside, okay? And that's one way to do it. The other way to do this is to go with a 4mm, have a shoulder on it, and put a nut on it. And if you're going to put a nut on the outside of this thing, you'll want to put 2 nuts. So one nut jams up against the other one, and then the nuts never come loose. If you put one nut on, in 6 months, it'll come loose, right? So these are all the things that we should be considering at this point. 57 looks good. Let's go 60. Nice thing about using metrics is most people will stick to an even number. Let's go 55. And I like that even better. Say okay. And now we have a shaft. One of the things that I see is if we draw one of them, we can mirror it to the other side, so it's half the work. Is that something that you would prefer to do?
What would be the most efficient?
Doing one side and mirroring it and then moving it.
Yeah, totally.
Yeah, so let's go ahead and change extrude 5 to a blind, and we'll only get half the shaft. And yeah, whoa. Now what we need to do is let's go, yeah, pick a number, 30 maybe. Let's see what 30 looks like.
I do that.
You can, but why? Well, because, yeah, go 25. Okay, you win 55 divided by 2. All right, so say okay to that. Now, the job is to create your counterbalance piece of sheet metal. So what I would do in this case is create a new sketch. I'm just going to tell you how to do it. I'm not going to explain it. So sketch. There is no sketch where we want it, so go to the make connector. Okay, that's my reference to the offset. Nope. I need for you to go off the origin. Click on the origin. And okay, that's fine. Just say okay. Now I want to reorient the make connector, so that's the smaller one. Yeah. And I want to turn my planes on. And I want to realign the direction of this newly created make connector. So realign. And I want to, now what it's asking for is the Z direction for the primary up above in the blue. It's already highlighted. If you pick the front plane, watch what happens to the make connector. And one of the things that I'm gonna watch out for is the positiveness of X and Y. I like that because Y is up. And then my sketch, we want to offset it. So down in the Z, we need to offset our first counterbalance. And go ahead and give me, hit the plus key. Keep going. Keep going. And now I'm watching numbers. 6 is about 1/4 of an inch. That's fine. And say, hit the X in the make connector box. So up above, I want to get out of the make connector definition. Okay. Now I'm creating a sketch. Do you want the counterbalance to spin inside the part studio?
Yeah.
Okay, that's going to be painful, but we'll do it, okay? And
Now
do
what is
you
the
want it to be tied to your layout? Yeah. So let's do this. I want to show you, there's 2 ways to actually create this counterbalance. One would be that it's static and we align it to some of the planes, therefore it's real fast and easy to draw. But what fun is that, right? What we really want to do is to be able to spin the layout. That means that all your geometry has to be located about the origin and cannot be tied down vertically or horizontal. It has to be free to rotate. We can do this. Let's go off and do it, okay? So let's just say okay to this sketch. I am going to force you to design this thing at an angle. So let's go back into layout, double click on layout. And instead of that being vertical, just draw it at an angle, because that's what we're forced to draw the counterbalance at the angle. You might as well try to match it up to the sketch underneath it. If you go to hit the N key on your keyboard and rotate it such that it matches the image below it. There you go. Yeah. And yeah, it's still a crappy image. Say okay to this. And let's go look at the image for the wheel. Turn the wheel on. Now turn the wheel off. Go inside the wheel folder and turn that image on. And neither one of them are any good. So we're just going to have to fudge it. Go ahead, turn the wheel image off and collapse that folder. And we're just going to have to make do with what we have. Okay, so now let's go into sketch 5. Double click it and edit it. Yeah. Okay, so I'm going to start cheating because I find it faster. So let's grab the short leg of the layout sketch. Now pick it. And hit U. Pick the black line and make it construction by hitting the Q key. So what this line's not going to do is create geometry, but it will allow us to put other references in there. The other reference that I want to put in here will be the offset. So up above, we need to go to the offset icon. So go up into your command line and go over to the left and over to the right. Okay, now that I don't want to offset, I want to open that one up and go to a slot. Pick that. And I want you to hit the Q key on the keyboard and accept that. Say yes. I like this. This is wonderful. Thank you. Scroll down a little bit. Oop, go back into sketch 5. And scroll, hit the F key on your keyboard. Change 20 such that it matches the diameter of the little piece of that counterbalance. Hit the down arrow, double click it, hit the down arrow key one more time, hit the N key. Hit double click that, hit the down arrow. One more. That, I like that one. Accept that. I need for you to now go up back to the slot, but I'm going to do an offset. The curve that has 8mm diameter, pick that. You see the arrow, the white arrow? Pick that. And say, okay, hit the enter key, pick white space. I don't know how to accept this stuff. 4, 3. You can't do that. So yeah, there you go. Let's try that for now. Say okay. The arc that has 8 millimeters defined, change that to construction. Nope. Pick the arc, not that one, hit Q. Okay, now I need for you to create a line, L, and pick the vertex to the left. Yeah, and go above and pick the blue. Nope. Okay, now this is what we got to be watching for. Oh, and it hit the Q key. Oh, too late. Delete it and do it again. There you go. Pick the vertex below that. Yeah, and okay. And now this isn't going to work. Wait, look, let's just go ahead and fix this. So pick perpendicular for a constraint.
What do you mean?
The constraint is up in the command bar. And not that, that's perpendicular. And pick the blue line and pick the black line that it's going to be perpendicular to. Pick the black line. Yep. Notice how it went black, and now you got another blue line down there, and you need to do it to that one too. Okay. Drum roll, please. Say okay to that sketch. And so this thing doesn't blow apart. Go into layout, double click layout, and move the small arm just a little bit. That's good, because if it's not right, it's going to blow apart and go to Timbuktu. Click on the word final up there in your sketch. You are so good. Do you see that when you change the layout sketch, that your counterbalance sketch is updating properly?
Yeah.
It didn't go to Timbuktu.
Yes.
It wasn't that hard to create a sketch that stays aligned to a layout, is it?
No.
Yeah. Okay, so let's say okay to this, and let's extrude sketch 5. First off, let's rename sketch 5 to counterbalance. C balance or something like counter, that's fine. You can spell it out if you want to. Okay, and now let's go ahead and extrude that out 2 millimeters. Possibly, I would do 3. And pick the word counterbalance. Pick this, nope, pick the sketch counterbalance. And not 25, let's go 3. And say, okay. Okay, well, that's way out of scale. The reason why I'm making this thick, Carson, is because you're going to press fit pins inside of this thing. If we make it 2, it's not going to last. So we got to make these counterbalances thick enough that when we push these shaft pieces into them, they stay in there. The thinner we make that counterbalance, the less they're going to want to press fit in, okay? If I look at this, it looks like they punched these counterbalances out, and then they're pushing those pins in, and then in about 9 months, this machine's going to fall apart. But that's just what it is, right? It's probably not very expensive. And these are the problems, you know. You better make those counterbalances out of some pretty good steel so that they can handle the loads. Of course, there's probably very few loads in this thing. The other thing that we want to do at this point is we want to put 4 fillets on that to represent where these things are going.
Should I do that inside the sketch, actually?
No, no, because look, you're rotating the sketch around and you're going to be farting around with fillets on the sketch. Don't do that. You know what I'm saying? Right?
Yeah.
This sketch is a nasty sketch because it has no references, no vertical, no horizontal references, which we normally do, and it keeps them stable. This one's free to spin around in space, therefore let's keep it as simple as possible. Back in the days of Pro Engineer, we would say that a sketch is not allowed to have more than 10 entities because they become unruly.
Got it. You're just scrolling down through a list.
What?
Were you saying like you're just scrolling through a list at that point?
Yeah, well, there's just too much going on.
Yeah.
You know, a lot of people think, oh, goody, it's all in one sketch. But the guy that has to edit that model later on, and he double clicks that feature, and there's 200 dimensions in there, you can't double click a face on a model and have it and have the ability to make a change. Your design intent is messed up. It's not a good practice to put 1,000,000 dimensions inside of a sketch. The next guy's going to hate you. So, and after all, right, designing is all about the next guy. It's not about you. Go ahead, change your dimension to 2 for your radius and go ahead and click those 4 edges.
Can I do a surface?
No, you can't. No, you can't. You got to pick the 4 individual edges. Pick, and then, oh, change it to 1, possibly change it to half. Yeah, let's go half. Actually, yeah. And go ahead and pick the other corner that we need a radius in. There's 2 more corners.
These ones?
Not that. Go ahead, just move over edges, and when you get over one, it's not that one, not that, not that, up that one, and the corresponding one on the bottom. Let's say okay to that. And I don't like the smallness of those radiuses. Let's double click fillet and make them a little bigger. And let's go 0.7. Let's go 1. And say okay. Let's go to the front view. Okay. Now, one of the things that you could argue with me is that that little tang is not perpendicular, like we said. That little tang has an angle to it. I'm going to ignore that. Okay.
Alrighty.
The other thing is, let's double click counterbalance and let's go to the 7mm diameter instead of 8, because I want to see more differential. Now, if you start doing FEA, you're going to need that. Okay, and if we do that, then let's, yeah, go ahead and leave that at 7. Delete the diameter offset. So we have a diameter offset for the counterbalance slug, not that, but the 3. There's a 3, there's a dimension, that other one, pull it out, and lo and behold, it was a 3, so delete it. And now put in a dimension. It's going to be a radius, but put in a dimension. And let's go ahead. I don't want that to be an offset. I don't want to change 7 and it changes this one. I want to change this one to 7. This is a radius. Say okay. Okay, now, so what did all this do? Go ahead and change the diameter 7, which is the diameter symbol 7. Double click that. That's the radius. That's not it. Go to the diameter. Change that to double click on the diameter 7, change it to 5. Do you see what we did? The diameter is not driving the counterbalance. These are now two separate features.
Okay.
Okay, so let's go ahead and put 5 to 6. Let's see how small this looks. And I like that best. Just say, oh, here's a question. You see where it says radius 7?
Yeah.
Change that to a diameter instead of a radius. You can't do that. Okay. So this is something that I don't like dealing in radiuses, mainly because when you do a lot of shaft work, you never refer to the radius. You're always referring to diameters. And I would like Onshape to give me the ability to change my dimensions from radial to dimetral. And anyway, they do most of the stuff that I ask them. Of course, I ask them thousands of things. Go ahead and say okay to this. And after all, it's not Billy CAD. So we have one counterbalance slug. Let's go ahead, rotate the model. And we need another one. Let's go ahead and make this 2 millimeters. Screw it, we're not gonna make this thing. So go ahead, extrude 6, double click it, change it to 2. It's just out of proportion.
Wait, we're not printing it anymore?
Okay, well, let's get it built and we're gonna scale this thing up. It's so small that the press fits, we need to make the thing bigger, right? The wheel needs to be, instead of 80 millimeters, the wheel needs to be 150 millimeters. Then all the sheet metal thicknesses and all of the stuff and the press fits are all gonna work better if we do that. So at this point in time, and if we do it proportional, the last thing we do is we scale everything. Now I'd blow a gasket if I opened up a model and somebody did that for real. But anyway, sheet metal part, what's the last feature in a printed part? Something that you're going to do, not a printed part, an injection molded part. What's the last feature in an injection molded part? They size it over 2% for shrinkage. It's not that magical. Most of the print shops will create that sizing for you. There are instances where you will scale the whole model, and an injection molded part is definitely that. They have to make the mold 2% bigger because when plastic melts, it shrinks by 2%. So this is not a good example of doing a global scale. How come we're in a sketch? Exit out of the sketch.
I thought you said change something to 2.
Yeah, I want to double click on extrude 6 and change it to 2. And say, okay, let's spin it a little bit. I mean, even that seems too thick, but that's better than 3. Can you grab size, extrude 5, counterbalance, grab all those features and put them into the folder?
Sorry.
No. Nope. One of them's already in there. Yeah, that. Go all the way down to the bottom. Shift, drag them in. Thank you. Okay, now what we want to do is we want to copy this counterbalance. So you want to go to your transformation command. Yep. And we're going to transform by XYZ, translate by XYZ, pick the counterbalance, because that's the body we're going to move. Oh, pick, no, well, yeah, no, you can't. Okay. We got, you want to go down and pick part 4 in your feature, yeah, down below in your parts. And we want to copy the part. So in your transformation, you want to pick copy part. And we're copying along the Z. So highlight Z, the distance Z, and hit the up arrow key. And turn it down. Oh, this is global coordinates. So yeah, let's go to, if you look at the global coordinate system, you can see that it's Y and you're going to move in negative Y. So highlight Y and hit the minus key. Keep going. Keep going. Now you need to put a knuckle on this. You're going to put a small shaft on this, so you better have more space than that. Okay, well, yeah, no, that's a bit out of size, but I would go 2 and more than, yeah, what? Yeah, you need to go, because that's material thickness. You need to keep going negative. One more, -4, and say okay. Now what we want to do is we want to do a, let's Boolean these all together. Union. And pick the shaft, the crank.
Am I doing that over here?
No, no, you can do them in the parts. So you can go down and you can pick part 4. Okay, we got some problems here. Go ahead and pick part 5 and say okay. And okay, that's fine. Now go into extrude 6, double click, extrude 6. It added it. We don't want to do that. Say new. The counterbalance needs to be a new part. It should not be part of the shaft. Say new. Say okay. Okay. Now we have part 4. Move your Boolean up to, move your roll bar above, or double click Boolean. One of them. We got to fix it. Okay. Exit out of that because I'm still not sure what's going on. Exit out of Boolean. Double click transformation. Transformation thought it was moving everything. Transformation is now assigned itself to move in the shaft. We don't want to move the shaft, so cancel that. Cancel part 4. No. Double click transform 2. Cancel that, yeah. And now what we want to do is, I want you, because I don't know what part 1, part 4, I don't know what part 5 is. I need for you to go pick the orange counterbalance on the screen. And say okay. Now let's do a Boolean and put double click on Boolean 2. You need part, nope. You already have it. It's just gone south on you. Hit the space bar on your keyboard. Okay, part 4, part 5, part 6. And say okay. Okay. Now let's zoom so we can see this thing. We've got a small problem, and that is this thing's not going to spin very good. Let's turn the image off. It's getting in my way. Let's turn bracket off. It's getting in my way. And down in your parts folder, turn off bracket. All right. Let's spin the part. let's put the counter, I don't even know what that piece of the crankshaft is called. The crank pin. We need to define the short pin that's part of our sketch. We need to click on the face of the counterweight. Yes, let's create a sketch there. Yes, let's create a circle. And put it at the center of, and not there, over to the left. Pick that center up. Draw me a circle. Oh yeah. Give me a dimension. And 2. And extrude that to the other side of the other counterbalance. And you want to go up to a face, not blind. You need to rotate your model and pick the face that you're going up to. That one. And for sake of brevity, we're just going to union them all together. We're not going to go over how to make this thing. So just say add.
Is it not on it?
What?
Isn't it selected?
Yeah. So just say okay. It tends to merge the features automatically, which I think is the correct way to do it. Now what we need to do is delete the crankshaft in between the 2 counterbalance weights. How would you do that?
Can you do like a remove up to face? Or
Yes, you can. But I wouldn't use that as my reference for that command. I would pick the interface of one of the counterbalances. No, that's the outer face. That's the interface. Create a sketch. Pick the edge, the inner edge, and use it. Nope. Nope. Yep. You. And extrude, remove up to the other face. Up to, you need to change blind to up to face and pick that face. And say okay.
Oh, I'm sorry.
No, you got it. What are you sorry for?
I didn't understand your original question earlier.
Yeah, well, it's hard to explain this stuff, you know, but it's better that you're doing it because now you're going to understand it. And you know what? You can watch these a million times. I don't care. Let's take all those features, drag them up into the folder.
Did I go too far?
You got to be below the fillet. Okay, so now what we need to do is define the crank over on the other side. And let's just mirror it to the other side, but we don't want it to, we want to create new. So mirror, this time it is part, so go ahead and click the part. The one time that it is the part, yep. And now the mirroring plane can be front, or it could be that face. I wouldn't have a problem picking the face either. Yeah.
Are you saying this face?
Yeah, I'm saying that I would accept that too as a good reference because it's always going to be mirrored about that. You know, I don't have a problem with you picking front. I don't have a problem with you picking the face because I think that that's a valid reference for this feature. Go ahead, turn your planes off. say, oh, change it to new. Notice how it wants to combine them. Change it.
Yeah,
to new.
yeah.
Okay, and say okay. Now let's do a transformation and rotate the second one. Go shift 7 so I know which one we're working with. And we want to rotate, transform, rotate, not translate, but rotate. And pick the one in the back. No, that's the one in the front. Pick the back one.
This?
No.
Oh, this one, sorry.
Yeah. That's why I go to F7, because now I know which is the front, which is the back. I'm constantly going to my ISO so my mind can understand what I'm working on. Go ahead and pick axis. We pick the part axis, and you can just pick one of the cylinders, the shaft. Pick one of the shafts. And we want it to go 180 degrees. Say okay. Boolean them together. Boolean. The front to, yeah, that's fine. Whatever. Say okay. Change part 4 to shaft.
Whoa, sorry.
And drag your, oh, crank. Change shaft to crank. I'm sorry. We should be consistent here. And drag those 3 features into crank. Let's go to our assembly. And let's import crank. Say okay. And what we can do now is you can just drag the crank a little bit out of the way. And what kind of mate would we use to make the crank to the, no, yes. And pick the center mate connector for the wheel. So you need to get in on that surface, zoom in, pick the inner diameter surface. No, you're picking the coordinate system. That's going to be a disaster. Hold the shift key down and grab the middle one. Yeah. Go pick the crank should be real easy to pick.
No, that one.
No. The center shaft.
Not here, but in here.
Yeah, the center of the shaft is going to go to the center of the pulley. That's it. Say okay. Say cancel the next one. Zoom out, which is F. Spin the wheel.
Okay.
All right.
It's awesome.
Easy. Now let's go back to the layout. And spin the, go into crank. You can turn a wheel on if you want. And go to your layout and change the direction. So go to layout, double click on layout. And click on final, show me the final display. And go normal, hit the N key. Grab your little arm and rotate them a little bit. Notice how the sketch is updating, not quite as fast.
Mm-hmm.
Say okay. Go back to the assembly. And did that move? Go to the front view. I want to see something. So here's the deal. The relationship between the wheel And we have no idea where that wheel is, to be honest with you. We have no idea where that crank arm is. Rotate the wheel such that the crank arm is horizontal. Grab the wheel.
Oh, this? Okay.
Yeah. Let's go straight on. Rotate the wheel down a little bit more so that it's horizontal. Okay, that's not more than horizontal. I want the crank to be horizontal. I want it to, yeah, keep going a little bit more. Okay, say okay. And now let's go back to the layout. Go into layout, the sketch layout for the crank arm. And just move that over to the other side. The short arm, move it over to the right, but not horizontal. Yeah, there you go. That's fine. Say okay. Okay. Hit Control Z.
Oh, sorry.
Okay. We have problems with our sketch. Go back to layout. Hit final. And let's rotate it up a little bit. Okay, say okay. Let's go to the front view. Let's go to the assembly. And the fact that you're changing the location of the crank in the layout is updating the assembly. I always thought that if once you put a part inside of the assembly, it no longer moves, but it doesn't. It is updating. So that's something that we have to note. So when we bring this thing into the assembly, we have to be cognizant that if we do rotate it in the layout, it's going to rotate it in the actual assembly. I think the rule of thumb is that once a part is inside an assembly, it stays put and it doesn't update. But it is updating. The location of the crank in the layout rotates. When we go back to the assembly, it's rotating in that assembly too. So these are things that we have to be mindful of. Go ahead, rotate the wheel here. Okay, and let's go back to layout. To be honest with you, I would not rotate the counterbalance in the layout because I've got two things going on. The sketch becomes kind of a mess. And I would prefer to have drawn the counterbalance in either a vertical or a horizontal position, and it starts to rotate when it's in the assembly. The other thing that I get is that I can put a counterbalance on the flywheel to counterbalance the counterbalance. And I can really tune this thing such that the center of gravity for the shaft with the counterbalances, with everything, will perfectly dynamically be centered. And let's go over here real fast. Click on wheel, click on crank, and then in the bottom left-hand corner of your screen, you see the scale in the bottom right-hand corner? The scale, the little icon, click that. Where's my mass? Oh, no mass because there's no density. So mass over, I don't know what to do at this point. Mass density, center of gravity, click on override. It should be able to tell us where the down, where it says center of mass, override it. Click on it.
You
Can you
can't.
click it?
No.
Doesn't do anything. Can you click on the word? All right, well, maybe I need to figure out how to do this. So what I'm looking at for this arrangement is I have a theoretical center, and then it's going to compute what the centers are. You know, maybe we make the wheel out of aluminum, maybe we make the crank out of steel. And if we put the mass in here, it's actually going to tell us where the center of gravity is. And we want the center of gravity of this thing to match up with our theoretical center. And then it won't wobble around on the table. Okay, so that's what I'm trying to do here that I was not able to do. But we'll assign mass. Let's go ahead and assign mass properties. Hit X up there. Let's get out of this command. Right mouse click on wheel. We're going to make that out of cast aluminum. So type in assign material for just click hit the space bar. Okay, pick wheel, assign it aluminum. Yeah, pick one of the parts, pick the wheel, and click on, not none, but click on aluminum, I guess. Type in AL, yeah, just aluminum. I don't know what a good cast aluminum is. Say okay. Pick the crank and let's make that steel. A stainless steel. Yeah, steel's fine. You can go with carbon steel. I don't care. Yeah, you can go with that. That's fine. Say okay. Okay, click those two and go down and hit your, how much does it, where's this? Yeah. And now click on front, click on the front view. Zoom in on your little target. Keep zooming in. Man, you're good. So if you look at the center of mass, look at how small those numbers are. You're off down in the microns. So how fast are you spinning this thing? How fast do you think this thing will spin? 100 RPM?
That'd be nice.
Yeah. So we're definitely in that realm. Okay. I don't know that you could spin this 20,000 RPM, but I don't know. I don't know how far off you could be. Go ahead and cancel that. Are you done? You want to go on for another hour and a half?
I can get ready for class.
Yeah. I think we're finished. I'll talk to you later.
Sounds good. Thank you.
Bye.
Bye.